Welcome to the chapter Force.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
Understand the idea of force and its effects. Define force, friction, tension, and pressure. Differentiate the contact and non-contact forces. Explain the force of friction. Identify the direction of net force in a given situation. Discuss the change in effects of force with area of contact. Draw free body diagrams. Identify the effects of force.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
In lower classes, we studied about the changes around us, like changes in seasons, changes during sunrise and sunset, changes in tides of sea, etc. Similarly, we have also learned how objects move. Do you know what are the reasons behind these changes? How can we decide whether an object is moving faster than the other? Let's find out the answers to these questions in this chapter. Let us consider some of our everyday experiences such as running, catching a ball, hitting a ball with a bat, goalkeeping, jumping, etc. Similarly, when we open a door, we put an effort on the door knob with our hands either to push the door forward or pull it backwards. Actions like picking, opening, shutting, kicking, hitting, lifting, flicking, pushing, pulling are often used to describe certain tasks. In all such activities, we are changing the state of motion of some object. That is, either the object is made to come to rest or to move faster or to change its direction of motion. These actions usually result in some kind of change in the motion of the object. Now, let us do a simple activity to identify tasks as push or pull or both. Classify these actions in terms of push or pull or both. In science, a push or a pull of an object is called force. Thus, we say that motion imparted to objects is due to the action of force. Force is a push or a pull. It can act on an object with or without being in contact with it. A force acting on body is either a contact force or force acting at a distance. Note: a force always need not change the direction of motion. For example, pushing a wall will not result in change of its motion. Let us know about the types of forces. Forces exist in nature that affect the movement of humans. A common classification is contact and non-contact forces. Force at a distance or field force. Force on account of direct physical contact between two interacting objects is known as contact force. The force which occurs without any physical contact between two objects is known as a force at a distance or field force. Let us know about the contact forces. Contact forces are those forces which act only when objects are in physical contact with each other and bring about necessary changes. The following are types of contact forces. They are muscular force, frictional force. Click each tab to know more. In all the actions that we perform in our daily life, like brushing, bathing, eating, writing, and walking, we have to exert a force. The force which we exert by using our body muscles is known as muscular force. All animals and human beings use their muscles to do work. The muscles exert force on the object that brings its motion. Muscular force can also change the speed of moving bodies. Muscular forces can be exerted only through contact. A ball moving on the ground comes to rest after moving through some distance. A vehicle comes to rest once its engine is switched off. We know that some force is required to stop a moving body. Therefore, some force must be exerted by the ground on them to stop them. This force is called the frictional force or the force of friction. We can define friction as follows. When two surfaces slide over each other, the force which opposes this motion is called friction. As the force of friction arises when the surfaces of two objects come in contact with each other, it is called a contact force. Let us know about the non-contact forces. Some forces do not involve physical contact between the bodies on which they act. They act through the space between them. Such forces are called non-contact forces or forces acting at a distance. The following are the types of non-contact forces. They are magnetic force, electrostatic force, gravitational force. Click each tab to know more. The force exerted by a magnet on iron objects is called magnetic force. The force which results due to the repulsion of similar charges or attraction of opposite charges is called electrostatic force. For example, a charged balloon attracts the pieces of paper. Newton's law of universal gravitation states that any two bodies in the universe attract each other with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, let us perform an activity to observe the motion of a ball on different surfaces. Click each tab to know more. Take a ball. Roll it on different surfaces like carpet, rough roads, smooth floor. Observe the motion of the ball on different surfaces. We observe that the motion of the ball is different in each case. Finally, we learned that the force of resistance to the motion seems to be more on the rough surfaces than on the smooth surfaces. The rolling ball moves faster on a smooth marble floor than on a rough sandy surface. Now, let us perform an activity to observe motion of the objects on an inclined plane. Click each tab to know more. Take a tray. Take a small ice cube, a razor, and a rupee coin. Place them on a line at one end of the tray. Now slowly lift this end of the tray. Observe their motions. In this activity, we observe that the ice block reaches first, the coin reaches later, and finally the rubber reaches the ground level. Finally, we learned that the friction is the resistance to the movement of a body over the surface of another body. We also learned that the direction of friction is always opposite to the direction of motion relative to the surface. The force or friction which opposes relative motion of surfaces in contact.
Knowledge check. Attempt the following questions to check your understanding.
Imagine that a book is placed on a table and it does not fall down because it is supported by the table. We know that contact objects exert force to each other because of their weights. Owing to this reason, the book exerts a force to table because of its weight, and table also exerts force to the book. In general, a direction which is perpendicular to the plane of a surface is said to be normal. Note: the attractive force between any two massive objects is called gravitational force. The force that a solid surface exerts on any object in the normal direction is called the normal force. In the above example, the downward gravitational force is being balanced by the upward normal force. Since these two forces are of equal magnitude and acting in opposite directions, the sum of these forces, that is the net force acting on the book, is zero, and the book is said to be in equilibrium. Imagine that a stone is suspended with the help of a thread or string and its free end is tied to the retort stand. We know that the stone would fall down due to gravitational pull or weight of the earth if the string is broken. For a stone tied to the thread, gravity pulls down the stone all the time, but it does not fall down because it is supported by the thread. Thus, there exists a force which supports the stone against gravity by pulling it upward. It is called tension, which always pulls the bodies along the string. The direction of the tension force is always away from the surface of the object to which the thread is attached. When we try to stretch a thread or a string, the tightness of the thread or string is called tension. In the above example, the gravitational force is balanced by the upward tension force. Now, let us do a lab activity to find out the limiting force that can be borne by a string. Click each tab to know more. The aim of this activity is to find the limiting force that a string can bear. The materials used in this lab activity are spring balance, weights, light strings, weight hanger. Arrange the system as shown on the screen. Put some small weights like 50 grams on the weight hanger. Observe the readings of the spring balance and note down. Now, add some more weights to the hanger. Once again, note the readings of the spring balance. Repeat the same process till the string is broken. Note the reading of the balance when the string is broken. Separate the whole system from the ceiling. Now take another string and tie its one end to weight hanger and other end to the spring balance. Place some weights like 50 grams. Now slowly pull up the whole system with your hand. Note the readings. Repeat the same procedure for various weights like 100 grams, 300 grams and 500 grams. In this activity, we observe that the force required to move the weight hanger over the surface increases with the increase in the mass of the weight hanger. Finally, we learn that the frictional force which opposes movement must also increase with the increase in the mass of moving object. The limiting force that a string can bear is the maximum load that we can hang from it without breaking it. The maximum tension with a string can bear is called its breaking strength, which depends upon applied force and material of the string.
Knowledge check. Attempt the following questions to check your understanding.
Now, let us perform an activity to understand the magnetic force. Click each tab to know more. Take two sewing needles. Take a ball magnet. Rub them in the same direction with a ball magnet several times individually. Now, the needles act like a magnet. Now take a compass. Identify the north and south poles of the two needles. Similarly, identify the south pole of the needles. Take a white color foam ball and pin it to the north pole of the needles. Take a red color foam ball and pin it to the south pole of the needles. Now take water in a bowl. Drop the needles in a bowl of water side by side so that their like ends with red or white balls face each other. Observe the changes. Now take them out. Once again, place the needles in such a way that unlike ends, one white ball and one red ball of each needle faces each other. Observe the changes. In this activity, we observe that the red end of one needle and white end of another needle attracts each other and that the ends with same color repel. Finally, we learned that the like poles repel or push each other and unlike poles attract or pull each other. This action of pull or push results due to a magnetic force. A magnet can attract or repel another magnet without contact with that magnet. Now, let us perform an activity to understand the electrostatic force. Click each tab to know more. Take a balloon, inflate it. Now tie up the open end with the help of a thread. Take a white paper, cut it into small pieces. Place the small paper pieces on the table. Take a balloon and rub it with another paper. Now bring the balloon near the pieces of paper. Observe the changes. In this activity, we observe that there is an attraction between the balloon and the paper bits even though the balloon is some distance away. Finally, we say that when the balloon is rubbed with a paper, it acquires an electrostatic charge on its surface. The balloon is now said to be a charged body. When it is brought near the bits of paper, the pieces acquire opposite charge and will rise and cling to the balloon. The force exerted by a charged body on another charged or uncharged body is known as electrostatic force. This force comes into play even when the bodies are not in contact. It is an example of a force at a distance. We observe that a ball kicked upwards always comes down to the ground. Similarly, a fruit detached from the plant falls on the ground. This is because earth pulls them downwards. This pull of the earth is due to a force called gravity. When we lift a dumbbell, we apply a force upwards against the pull of the gravity. Similarly, if an object is thrown upwards, there exists a force which pulls it down towards the earth. Because of this, it falls down on the ground. We call this force as gravitational force. Every object on the earth or close to earth will experience a gravitational pull. The force of gravity is not just due to the attraction of the earth. It is a force of attraction that exists between any two bodies or masses everywhere in the universe. The earth is so massive and huge that all the other objects close to the earth are attracted or pulled towards it. The force which acts between two bodies when the bodies are not directly touching each other is called force at a distance. These forces can be explained by using the concept of a field. Let us do some activities to know more about the forces at a distance. Now, let us perform an activity to visualize the magnetic field. Click each tab to know more. Take a bar magnet. Put it on a table. Take a white drawing sheet. Place it over the bar magnet. Now take some iron filings. Sprinkle them on the paper. Now tap the table gently with pen or pencil. Observe the changes. In this activity, we observe that in a small space around the magnet, iron filings set themselves in a pattern because they are affected by the magnetic force of the field created by the bar magnet. So, the pattern represents the magnetic field. The space around the magnet where its influence can be detected is called the magnetic field. Finally, we learned that every magnet has an invisible magnetic field around it. This field is made up of lines of force that attract magnetic material such as iron filings. The filings form a pattern as they line up in the direction of the magnetic lines of force. Thus, we say that a field is a region in which a force can be experienced by another object placed at any point in that region.
Knowledge check. Attempt the following questions to check your understanding.
Practically, many forces can act simultaneously on a single body. For example, consider an object placed on a horizontal floor. In this situation, two forces act on the object, where one is the gravitational force and the other is normal force, which acts vertically downwards and vertically upwards respectively. In this case, the forces acting on the object are equal in magnitude and opposite in direction. Hence, there exists no change in the state of the object. Technically, the net force on the object is said to be zero, as the state of the object does not change. The sum of all forces acting on an object called net force. Imagine that the same object is placed in a lift which is accelerating. In this case, the object is in non-uniform motion. So, the net force acting on the object is not equal to zero. When two forces act on a body, as in the above case, one of the forces should be greater than the other to set the body in motion. The strength of a force is usually represented by its magnitude. The direction of a force is as important as its magnitude. We represent the direction of force using arrows. Now, let us perform an activity to observe the effects of net force acting on an object. Click each tab to know more. Choose a heavy object like a table that you can move only by pushing hard. Try to push it. Observe the changes. Now ask your friend to push in the same direction along with you. Observe the changes. We observe that it is easier to push the table when you take the help of your friend. The force applied by your friend added to the force exerted by you results in both forces being applied on the table in the same direction. The total forces applied by both of you makes it easier to move the table. Now, ask your friend to push the table from the opposite direction to you. Observe the direction in which it moves. We observe that the net force on an object is zero if the two forces acting on it in opposite direction are equal. Finally, we learned that all forces have both magnitude and direction. While adding forces, the directions of forces have to be taken into account. When forces act on a body along a straight line and they are in the same direction, the net force is taken as the sum of all forces acting on the body. The sign convention must be used to add forces. The force F1 directed towards right could be taken as positive and the force F2 acting towards left could be taken as negative. If F1 greater than F2, then net force Fnet is equal to F1 plus minus F2 is equal to F1 minus F2. Finally, we conclude that if the two forces act in the opposite directions on an object, the net force acting on it is the difference between the two forces. The object at rest moves in the direction of the net force acting on it. Now, let us perform an activity to know the effects of stretched rubber bands on fingers. Click each tab to know more. Take a rubber band. Stretch it using your fingers. Observe the force from your fingers. Now take one more similar rubber band. Add it to your fingers and stretch both together to the same length. Observe the force exerted on your fingers by the rubber bands. Repeat the same procedure by increasing the number of rubber bands. We will observe that when we stretch the rubber band, it exerts force on our fingers and feel the force of pull on our fingers. Similarly, we also observe that the combination of two bands exerts a larger force than that of one rubber band. Assume that the force exerted by one rubber band is F units and the force exerted by the second rubber band is F units. Then the net force of two rubber bands is shown on the screen. The unit of force in SI system is Newton N. The diagram showing all the forces acting on an object at a particular instant is called the Freebody Diagram. It is denoted as FBD. Assume that a car is moving with a non-uniform speed on the road. Choose a coordinate system with x and y axis. Sign convention is to be taken along x and y directions. The forces acting on the car are shown in the FBD are: force applied by the engine is equal to capital F. Friction applied by road is equal to small f. Normal forces are N1 and N2. Gravitational force Fg is equal to W. Net force along x direction is equal to small f minus capital F. Net force along y direction is equal to N1 plus N2 minus W.
Knowledge check. Attempt the following questions to check your understanding.
Now, let us do an activity to understand the effect of force on the state of motion of an object and its direction. Click each tab to know more. Take a football, place it on the ground. Now ask a player to kick the ball towards the goalpost. Now ask the goalkeeper to stop the ball. Note the observations. We observe that the ball was at rest and so its speed was zero before it was hit. The player applies force on the ball that moves the ball towards the goal. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. The force applied by him can stop or deflect the ball, saving the goal. If the goalkeeper succeeds in stopping the ball, the speed of the ball decreases to zero. Finally, from these observations, we learn that a force applied on an object may change its speed. If the force applied on the object is in the direction of its motion, the speed of the object increases. If the force applied in the opposite direction of the motion, then decreases in the speed of the object. Now, let us perform an activity to understand the effects of net force on direction of moving object. Click each tab to know more. Hit a carom coin with a striker. Now ask your friend to do the same. Observe the direction of coin in each case. In this activity, we observe that the direction of the coin changes in each case. Similarly, we also observe that while hitting the coin with the striker, not only does the coin change its direction, but the striker changes its direction too. Finally, from these observations, we learn that net force stops a moving object or makes a stationary object move and also changes the speed and direction of a moving object. Thus, force can change the state of motion of an object. Identify the shape of the objects carefully before and after applying the force by clicking the appropriate answer. A force not only changes the state of motion of an object, but can also change the shape of an object. It may change the shape temporarily or permanently based on the nature of the object and the force applied on it. Now, let us perform an activity to know the change in effect of force with area of contact. Click each tab to know more. Take a pencil. Push its rounded end on your palm. Now push from the other side of the pencil so that the sharp end is on your palm. Observe the changes. We observe that the effect of force depends on the area of contact on which the force is acting. When there is a decrease in the area of contact of the force or load, then the effect of force increases and vice versa. The force acting perpendicularly on a unit area of a surface is called pressure. That is, pressure is equal to force by area. The SI unit of pressure is Newton per meter square or N by m square. Now, let us perform an activity to identify the effects of force. Click each tab to know more. Take two trays. Fill both the trays with fine sand. Now take two rectangular bricks of equal mass and similar shape. Put one brick vertically in one tray. Put the other brick horizontally in the second tray. Observe the changes. We observe that the brick standing vertically sinks deeper in sand than the brick standing horizontally. The depth to which the brick sinks in the first tray is deeper than that in the second tray. Finally, we learned that if the contact area or the surface area on which force is acting is smaller, similar than the pressure exerted by the brick is more or vice versa. For a given force, if the surface area is smaller, the pressure will be greater. If we use a larger area, we are spreading out the force and the pressure becomes smaller.
Knowledge check. Attempt the following questions to check your understanding. Keywords. List of keywords are shown on the screen. Summary. Let us recap the highlights of this chapter.
In science, a push or a pull on an object is called force. Thus, we can say that the motion imparted to objects is due to the action of force. Force is a push or a pull. It can act on an object with or without being in contact with it. Force, which results when there is a direct physical contact between two interacting objects, is known as contact force. The force which occurs without any physical contact between two objects is known as a force at a distance or field force. The force which is exerted by using our body muscles is known as muscular force. We can define friction as when two surfaces slide over each other, the force which opposes this motion is called friction. The force which a magnet exerts on iron objects is called magnetic force. The force which results due to the repulsion of similar charges or attraction of opposite charges is called electrostatic force. The friction is the resistance to the movement of a body over the surface of another body. The direction of friction is always opposite to the direction of motion relative to the surface. The attractive force between any two massive objects is called gravitational force. The net force on the object is said to be zero. The state of the object does not change. The diagram showing all the forces acting on an object at a particular instant is called Freebody Diagram. It is denoted as FBD. A net force stops a moving object or makes a stationary object move and also changes the speed and direction of a moving object. Thus, a force can change the state of motion of an object. A force not only changes the state of motion of an object but can also change the shape of an object. The force acting perpendicularly on a unit area of a surface is called pressure. The contact area or the surface area on which force acts is smaller, the pressure exerted by the brick is more or vice versa.
Read the questions and attempt the answers on your own. You can click Answer for your reference.
Follow-up work. Collect pictures from various sources like internet, magazines, newspapers, etc. to illustrate contact forces at a distance and prepare a scrapbook. A cricket ball of mass m is thrown upward with some initial speed. If the air resistance is neglected, what forces are acting on the ball when it reaches A. half of its maximum height, and B, its maximum height.
Test your understanding of the lesson by taking the mock unit test.
You have successfully completed the chapter Force.